Good morning, everybody. Welcome to the second day of Geointelligence 2022. As you may be aware, we are running 3 tracks today, one on space, this track on defense, and a third one is an industry user meet, which is on internal security and disaster relief and management. So we have a day packed with experts, and I won't take much of your time introducing this defense track, but nevertheless, I have a small text prepared for you. In today's environment, the need for a credible defense capability and its linkages with the rest of the determinants of this capability cannot be overlooked by any country. In the context of dynamically evolving global geopolitical scenario and deterioration of the security environment, this is an absolute necessity and not a choice. The current security environment is turbulent and conflict prone due to territorial disputes, ethnic minority issues, separatist movements, and Islamic extremism. We face threats such as cross-border terrorism, human, narcotics, arms trafficking, organized crime, and piracy. Today, technological developments, particularly in the field of information technology and a variety of engineering disciplines, are redefining how wars will be waged in the future. The pervasive influence of these advancements on geographical information systems is a well-known phenomenon. The need for geointelligence is at an all-time high with unstable geopolitical situation and rising terror threats across the globe. Armed forces use geospatial technologies in a variety of applications, including intelligence, battlefield surveillance, and terrain analysis and infrastructure and logistic management. So with these words, we get straight to the first session of ours, which is on resilient PNT and ISR capability. And we have 4 speakers, and I'll request them to come on the stage as I call out their names. Lieutenant Colonel Gulshan Mehta, Dr. Rao, Tommy Hulton, am I pronouncing the name correctly? Lieutenant Colonel Vivek Gopal, and Commander Mukesh Saini. Please be seated, gentlemen. So I shall briefly introduce the first speaker. That's Colonel Gulshan Mehta. He is an officer of the Corps of Electronics and Mechanical Engineering, and he has over 13 years of service. He's done his MTech in Telecommunication System Engineering from IIT Kharagpur, and he's currently posted with the Simulator Development Division, which is the only research establishment of the Indian Army. He's an expert on augmented reality and virtual reality. And the products that they have been developed by the SDD have been accepted in the Indian Army. He's also done his post-graduation in computer technology from the Military College of Electronics and Mechanical Engineering and trained on UAV systems as a UAV systems engineer from the Air Force Training Establishment at Bathinda. He has represented our country in Bangladesh, where he installed and trained Bangladesh Army on VR-based 84mm rocket launcher simulator developed by him while he was recently, and he was also recently awarded the Chief of Army Staff's Commendation. I request Colonel Gulshan Mehta for his talk, please.
Good morning, ladies and gentlemen. At the onset, I would like to thank General Chandele to invite me to this August gathering and give my views. The topic that I've selected is the interference detection and mitigation solutions for resilient PNT system. We are aware that there are large number of navigation satellite systems using which we carry out this PNT task. The first four are the global navigation satellite system, and the last two are the regional satellite system. The GPS, which was developed by US, gives us an accuracy of, on an average, 5 meters. However, if in case we use L5 band, which has almost 16 satellites, we can get an accuracy of almost 30 centimeters. However, due to paucity of these satellites and their availability in very limited areas, we cannot use this specific band for our own navigation system in India. However, it is expected that US is planning to increase these satellites from 16 to 24 by 2027. During the Kargil war, it was observed that US downgraded their facility and the accuracy has gone down drastically, and hence we were not able to use the satellite system. Even Russia thought, and hence they came up with the GLONASS system, and the European Union came up with Galileo. The accuracy which is given by Galileo is almost 1 meter, which is what we require as a defense system. India also realized that we should also come into a navigation system, and hence, instead of going into a global navigation satellite system, we came on to a regional-based navigation satellite system. And in 2018, we were ready with almost 7 satellites in space. We are able to give an accuracy of 1 meter, which is what it was required. Japan also came up with a quasi-zenith satellite system, which is also able to give a regional accuracy of almost 1 meter. There are large applications of GNSS system, starting from PNT to tracking, autonomous driving, updation of maps, like sir mentioned about the terrain analysis. All for everything we require accuracy in terms of position, navigation, and timing, for which the GNSS is one of the most important backup data which is available to us. For military, security, surveillance, guiding the bombs, missiles, carrying out operations, again, we are only and only rely on this GNSS system. Talking about the PNT system, the GNSS system or the Global Navigation Satellite System is the only way where we can get the assured PNT. That's the way to determine the correct geographical location, calculate the path, and maintain the time. However, as I said, accuracy is a big question mark. 25 years ago, the US military commanders, they used to ask, why do we need to take a trouble of using this GPS system? However, now those same commanders in the present scenario, they say that GPS is so much successful. Why are we talking about something else? So it means we need to discuss about the future technology. Charlie Trimble, the founder of Trimble Incorporations, he said that smartphone is a wonderful example which proves how far PNT has integrated into our lives. All of us are using this GNSS system or the PNT system in routine. Talking about the resilience in this PNT system, there are a large number of technology which exist. The most basic is a ground-based PNT system, which we use again and we are not aware. In this concept, the ground-based towers or the ground-based Wi-Fi terminals, they are aware about those locations and they transmit those locations. We get those locations on our mobile. That's how we get an accurate navigation through our Google Maps or Map My India. The ground-based augmentation system is being used by the airlines to carry out the accurate navigation while taking off and landing. In this system, the GNSS system is augmented by additional information which improves the accuracy of the PNT. Carrying out hybrid sensors and hybrid technology, we can get hybrid and autonomous PNT system which increase the overall accuracy by many folds. To assure the the correct PNT, there are a large number of technologies which includes anti-jamming technology, anti-spoofing technology, military code receivers, inertial measurement unit. Now, initial measurement unit, it has its own inherent, errors. However, to overcome those errors, the image-based terminal guidance assists a lot. The interference is one of the most important parameter which drastically reduces the accuracy. Most of our military system, as I said, they rely on these GNSS signals. It's our duty to protect the signal against interference and the denial of services attack. This can be done only by protecting, toughening, and augmenting these signals by additional sensors so that the accuracy is improved. It's our duty to have resiliency in compromised environment, which is paramount to ensure mission reliability and mission success. As I said, there are a large number of techniques which are available, and augmenting the system is one of the easiest and basic system, wherein we have some additional sensors, we have some additional multi-GNSS constellation that we can use to increase the accuracy. Encrypted signals are the specific signals which are meant for specific users, and because of the encryption, it is tough. I cannot say it is impossible, but it is tough to degrade the signal. If in case we move on to NAVIC or IRNS system, it is easy for us to use the encrypted signal. During the Kargil war, India approached US and they denied to give us this encrypted signal for this GPS system. So it should be our endeavor to make our system much more robust by having the sensor fusion in the military system. We have LIDAR, we have radar, we have the technology, but the intent is that's much more important. The pseudo satellites, that's known as pseudolites, are the ground-based satellites. They behave like satellites. They are not actually satellites, they are pseudo satellites, but they give you the signal which is required for these sensors. There are a large number of companies which are working like Elora, Sattels, NextNav, Locata. They are giving you the solutions, but we want some good Indian companies that to work on this specific technology and to give us a resilient PNT system. Elora gives a low frequency radio navigation system which is built on international standards and hence provide a high power PNT system. A quick word about NAVIC. NAVIC is basically navigation with Indian constellations. India in 1999, during the Kargil war, as I said, realized that we need this NAVIC at a very faster pace, and hence we had 3 geostationary and 4 geosynchronous satellites in our own area, because of which we are able to get an accurate signal. The NAVIC consists of various ground segments wherein the ISRO ensures that all these satellites are in their correct location and they are able to give the correct position, navigation, and timing. Because of these lasers, ranging stations, and data communication network, all these satellites are synchronized and ensure a high accurate system. NAVIC basically provides special positioning service for the local, you can say the commercial world, whereas the precision service is the military grade service where the accuracy is much, much better. It works on L5 band and hence it is able to give better services than others. The position accuracy presently is less than 10 meters over India and it's almost 20 meters over the Indian Ocean region. The overall coverage of this system is almost 1500 kilometers. This is one of a major reason where we can also proliferate this system to the friendly foreign countries, friendly neighboring countries, since we are able to give this complete, you can say an accurate navigation system to their countries. So the final applications of the NAVIC, we need to take a call whether India has done enough to harness the NAVIC potentials. Why are we so much relied on GPS, even if in case the accuracy is low? Why don't we want to switch over to our own system? In 2019, India made it mandatory for all the cabs to have these sensors. But do we still have these sensors? We need to think on. Recently, the National Highway Authority of India is planning to remove the FASTags, and they are planning to have these NAVIC sensors placed on the vehicle, so that your toll detection is done automatically once you are on the highway. So now you need not to pay the tax for the complete area. Only the road that you have traveled, only that much you need to pay. And that is possible only by an accurate PNT system. Moreover, I just need to bring out again that there is no treaty between India and US wherein they promise us to give an uninterrupted GPS signal. So that's why we need to have our own system. Just a quick word about the Ukraine war. We are aware that the Russia carried out a localized jamming of GPS signal from Finland to Black Sea, because of which the complete operations were hindered. They were unable to direct the artillery fire. Ukraine had large number of smart munitions, missiles. However, because of their optical system and not reliance on a GPS system, they were able to achieve the terminal objective which was achieved. Moreover, the Turkish Bayraktar TB2 also works in the GPS denied environment, and hence they were able to achieve what they had desired. With this, I just would like to quote what Gillian Smith, the Vice President Marketing of NextNav, said, that US is almost doubling the revenue in 2 to 3 years of GPS. However, the GPS is signal point of failure, and hence it highlights an important need for a resilient PNT system. Jen.
Thank you, Gulshan. You had the first mover advantage, so you could speak over the wide range of this subject. Our next speaker is Dr. Rao, who is currently working as Vice President Sales, Middle East, Africa, Southeast Asia for Capella Space, the first US-based commercial SAR company. He is an accomplished senior executive in international sales, business development and marketing for over 25 years that has worked with a number of companies. It will take me a lot of time to read the names. Over to you, Dr. Rao.
Thank you, sir. I'll quickly give you an overview of Capella Space, the only and first synthetic aperture radar satellite company from US with 7 satellites in the orbit. What you are seeing on the screen here is the Chinese satellite launch facility. This presentation I will be presenting, but my colleague and friend, Mr. Kumar, CEO, Remote Sensing Instruments, our partner from India, he is here in the audience, he's sitting there. So this is a combined presentation of ours. Capella has got 7 satellites in the orbit, 2 more are going this year. They are in different inclinations, 45, 53, 97 degrees. So with these different inclinations, we will be able to cover any target about 3 to 4 times in a day. Any target 3 to 4 times in a day. Those days are gone once in 3-4 days of revisit. Just this is how the satellite works. It flies highly agile satellites. They can turn right to left and image with different look angles, and both on land and water, correct it and downlink to the nearest ground station. And then we uplink immediately to the Amazon government cloud, process the product and deliver the product to the customers. We operate in 500 megahertz of bandwidth, which gives us 30 centimeter resolution on the slope. The resolution of the SAR in the range depends upon the bandwidth, as most of you know. So we are able to get 30 centimeter. When you project it to vertically down, it becomes 50 centimeter resolution. In Azimuth, we get 50 centimeter or better. But we can offer only 50 centimeter because of the license limitation. There are three modes of collections. Spotlight, which is 9 looks, which gives you 50 centimeter. Sliding spotlight, which is 5 looks, gives you 1 meter. And strip map gives you 1.2 meter with single look. So what is the advantage of 9 looks? You can see here in this image, the first first column of images are single look, where you see the salt and pepper appearance on the image, which is common in synthetic aperture radar images. Whereas in the 9 looks image and the next row, you can see the noise has been removed and a very clean image is produced. And that is what we offer to the customers with the highest resolution, where interpretation is much easier. Just to mention about the unmatched and temporal and orbital diversity, just an example I'm showing you here in the Ukraine region. On a single day, you can see how many images we collected over that region to support the troops. And we have been providing this the imagery to both Ukraine government and also US government. And all our 7 satellites are fully tasked over the region. We are not able to take any orders from anybody else to serve them. But we offer whatever is collected within 15 minutes on the catalog, and the customers can download the imagery as the archive imagery. So that's how you are able to serve the other customers in the region. Well, Capella offers, we call it as a console, an interface with the API. It runs on our API. We also offer an API to the customers to integrate with their systems. We hand over the tasking of the satellites to the customers. If any customer who signs with us, we give them access, they task the satellites. We don't task the satellites for them. So in 15 minutes time, he can finalize a task, and within 15 minutes, the task is accepted and satellite is tasked with the collection, and satellite collects its downlinks and delivers. And customer will also know when he's tasking, in the middle chart you can see, the moment he puts a point on a location, I want to collect this location. In next 7 days, what are all the passes and what time the satellites pass are listed, and you can download as a CSV file. So you can decide which range of time you want to task the satellites. Once the tasking is done, the status of the task is available to you online, whether when the satellite is tasked, when the satellite is collected, downlinked, processed, delivered, QA and delivered. Entire thing is autonomous. There is no human beings in between in the entire chain of your order to your delivery. This is how the total system works. You task the satellite, it goes up directly to the satellites via our console. Or we also have an arrangement with the Inmarsat satellites, geostationary satellites. We can actually program our satellites through Inmarsat. So we are able to, every minute we can task our satellites. But now we decide about every 15 minutes updating the tasking is more than enough for this commercial requirement. And the satellite collects any of the area of interest locations anywhere in the world. Downlinks, as I mentioned to you, and then Amazon Cloud, we keep our entire data and processing on the Amazon Cloud. We don't have a ground station and processing in our facility. Everything is delivered on Amazon Cloud and then delivered to you. The whole process, we have seen several, after tasking the satellite collection to delivery, we have seen 3 to 6 hours of delivery with the current set of ground stations we have. We use several ground stations globally. I'll quickly show you some of the examples of defense and intelligence targets, how they look in synthetic aperture radar. Here is an example of Russian S-400 surface-to-air missile, and you can see in the circles 3 of them with their barrels pointing to the sky. So those days are gone when synthetic aperture radar is more of a medium resolution and we are not able to see the details. Here now we are able to give you a product which looks like an aerial photograph, a black and white aerial photograph, which you are all used to in image intelligence. And here is another example of newly deployed Russian military troops. Here is another example. Move. Stuck. I can use the key. Yeah, it's moved now. Here is another example of I think the screen projection is so coarse. I'm sorry. If anybody wants to see, I can show you off the laptop later. You can see the barrels of the armed vehicles. Here actually you can see bomb damages in this location. A helicopter has been damaged here, a couple of bomb damage sites. Here are the vessels you can see. As we are seeing in a side-looking angle with synthetic aperture radar, we can see the vessels, their mass, what type of structure is there. A Navy expert can interpret what type of destroyer it is. And of course, then a layman like me. Here is an example of different types of aircrafts, how they look in SAR imagery. The engines, because of metal and corner reflectances, they come as bright spots. Here is an example from near India, the Hotan airport in China, north of India. You can see here there are two different days, 20th February and then 5th June. If you see the runway was smooth on the first date of collection. The second date of collection, the runway is very rugged. I understand it's a concrete runway. It's not a smooth asphalt runway. And because of the snow they use and they have to refurbish frequently. And I understand this is actually, when they refurbish, they laid some mats or rough material to hold the moisture for curing. So which you can see the runway is so rough. And now the aircrafts cannot take off from there. Here is some of the examples of Indo-China skirmishes during 2021 in the Ladakh region. Here is the example of China and India troops against each other. The distance between the tanks is only 160 meters. Luckily, they didn't fire with each other. The efforts of negotiations came fruitful and they withdrew from the area. And you can see here the first day with the troops against each other and subsequent dates when they withdrew from the same location. And here is another example. They did not go far. They went only about 90 kilometers away from the border. And you can see the facility where they are building 98 kilometers on Rotag. They are building the whole facility there. You can see the several vehicles and tanks. On 7th February, this is on 14th March, you can see how they have increased. And this is the facility on 16th June. And these are the details of the several facilities, how it is being expanded in that area. And a huge facility and developed. One interesting feature what I observed on June 16th is, you can see here, this is a typical launch missile, surface-to-air missile launch site of Chinese troops. And here are some examples of vessels. You can see US vessels in San Diego Naval Base. The lower one is the helicopter carrier. These are the destroyers you can see. Here is an example of Indian Navy in Mumbai port. You can see the vessel very clearly with the two clear masts. And the next one is of interest. The Port Blair, you can see, I saw this vessel and I saw it must be a cruise vessel. It must be a lot of tourism in Andaman. But I was corrected by one of my friends from the Indian Navy. No, this is a floating dry dock. I think only country in the world which has a floating dry dock. And the floating dry dock can take the vessel into it and then repair and put it back. Great technology. Congrats, guys. And here is an example of Chinese aircraft carrier. So we offer you assure you, if you want, you can take a regional capacity over the region of interest, and all the satellites are several specific satellites capacity fully can be owned by Indian users. And you monitor the areas, you detect, and carry on with your analysis. And we also offer some analytic products. We are already offering the vessel detection as an automatically generated layer using our imagery, and then we mark all the vessels in that image and deliver you a GIS layer ready to use in your GIS environment and integration.
Dr. Rao?
I'm done, sir. Thank you.
Yeah, good. Thank you. Thank you very much. Our next speaker is Tommy Hulton, Senior Director, Business Development, Maxar.
Thank you so much. Good morning, ladies and gentlemen. Very good morning to you all. And thank you for choosing this track. I hope we will all, my distinguished colleagues, make it worth your time. I've been 35 years in the aircraft industry, military and civil, and I've been since the beginning of 2017 with Maxar. I will discuss the globe in 3D. We are using Maxar's world's largest commercial image library to build the globe in 3D. We already have built 46 million square kilometers of the land mass of estimated 150. So about a third we have already on the shelf. And we build it geocell by geocell. Right. So quickly how we do it is that we select an area. Typically we do it geocell by geocell, but we also do it customer design areas. You will always find the data and the accuracy 3 meter XYZ SE90 with the resolution of 50 centimeter. It's always automatically done. So we just go in and select an area, go to the library with our algorithms, pick out the relevant images, and then we take the metadata from each and every one of those pixels, and then we build a mesh, and then we drape it with texture. It's big data processing. So the mother of the 3D data model is the precision 3D surface model, and from that we can extract rasters like the DTM and the DSM, surface model and the terrain model. Terrain model being all the man-made and grown objects scraped away. We talked about the capacity. We do about 2 million per month square kilometers we can produce. I will talk a little bit, focus a little bit more about the use cases because I think you will find that interesting. We will also dive into the future a little bit. And my 35 years in the aircraft industry will shine through a little bit. I'm sorry, but it's a good use case, I think. So the 3D model, this is a typical one. Again, the resolution, 50 centimeter, 3 meter accuracy, SE90. Examples of the other products that we derive from the mother model: digital surface model, vector buildings, we can vectorize them with height attribution, and the digital terrain model where we scrape off all the grown and the man-made objects. Very useful for our customer is the classification. We identify the clutters, and then the customer can remove it and replace it with their own. And very important for example, what happened here? Don't do anything without me. For example, when we do a radio propagation analysis for the 5G network, we need a line of sight. So we need to have sharp buildings. These are the standard clutter classes, but of course we also offer customized. If you particularly want to find railroads or something like that, bridges or something like that. Our customers always say, well, why would I need a 3D model of my area? Why is that so important? Well, this is a little bit childish example, but it's so very speaking. I mean, it tells me this is exactly why you need a 3D. If you look at your left, you will see the traditional mapping. And this is from the real world. You come from the road on your left, and you go up to the plains in the middle of the picture. So the traditional map says, yeah, well, you just put in your 4-wheel drive and you go from A to B. But in real life, with the Maxar 3D map, you will see that it's not just woods. It's 35-meter cliffs, 90 degree. So 4-wheel drive won't cut it. You need a rotor on your roof to get there. Typical example. But I mean, if you don't have this information, you either have to abort your mission or take another route, which could be very dangerous because you haven't planned for it. Typical defense capabilities that our data is used for. It's training and simulation, where we actually put the real world, the geospecific images in your dome or whatever training devices you are using. Mission planning and recce, of course. Precision targeting. X and Y, we have been able for many, many years to be very precise. But the Z, that's the elevation of the target. That's very important. So with this data, you always get a minimum or a maximum, I should say, of 3-meter precision. And the use cases are endless. Now, I'll give you another example, disaster management. You do the flooding analysis. This is a typical area. And then when we increase the river by 2 meters, it will look like this. And another 3 meter up to 5 meter, it will look like this. Typical use cases, very, very valuable. You do it over countries and regions, not only small municipalities. In the geodata concept, this is one example from one of our customers, and that customer is official. It's the US Army, who has bought One World Terrain, where they actually used the Maxar 3D data as the base layer. And on top of that, you put insets, very high resolution insets like millimeter resolution for special blocks in this city, for example. You put in vectorized data on top of it, of the Maxar data. You do models. You can put in your own models, and you connect it with the bathymetry. And the Maxar base layer, data layer, make sure that everything is aligned. So you put something on top of it, and we will correct it with our P3DR technology. It's called P3, Precision 3D Registration. So whatever you put in, we will compare the pixels and geo-correct it. So you get your 3-meter accuracy, whatever layer you put on top. And how many layers is the typical question? We haven't reached the limit yet, so I can't answer that question until we have put so many that it says stop. This sounds like it requires a lot of data. I'm using my laptop. This is not my laptop, a normal laptop, to do this exercise. When I put a photo and I geo-correct it, I can also use the photo to put me somewhere in space. So in this example, you're looking at something with an optical sensor. You geo-correct it because we also do full motion videos. And then you know where the camera is, in this case on board the aircraft. So this aircraft knows where it's at by 3 meter, X, Y, Z. And it's passive. It's only using the camera, so you don't turn on the radar. You're not using your flashlight in the middle of the night. So this is very important. This is now getting into the future. GPS denied, GPS spoofed navigation. I will not go through the process overview, but I've explained it to you. We have the base layer. We put on top whatever extra layers we want, and it will be geo-corrected and give you the same better high resolution, more information, same accuracy, 3 meter XYZ. Typically, you will see on top, the top picture here, this is the normal drone picture. They are normally 30, 40 meters off and also turned or twisted. And with our comparing pixel by pixel, it will be corrected. We built for an air show in Bangalore. We produced a very interesting area, northwest to your neighboring country. We flew the Gripen simulator, the Saab Gripen simulator, in that environment. And the pilots, the Indian pilots, were very excited because they have, not so many have flown there. And you can practice your mission in the real environment. It's not typical. The stones that you see, they are there. You can overlay threats. Surface-to-air missiles you can put where your recce have identified them, and you can plan your routing. We built this whole area in 48 hours for the air show. I think you get my point. I will continue. Right. Now we have actually on the same Gripen fighter aircraft, we are using the onboard already existing sensors. And that's what you see in the middle of this picture. Is it working now? This is also video. So the picture in the middle is what you see, and the data layer inside is the Maxar 3D surface model. And you can compare the roads. We are flying in about 800 kilometers per hour, and you can see how smoothly it follows. It's a little bit slow start, the same as me. On top of this big image, you can also see the signals, and you will notice that we will fly through clouds. But we can still compare whatever we see through the clouds, we can compare with the database, and it will correct us. All right. This is my last picture, so I will conclude. What you have heard me talk about today is how we build the globe in 3 dimensions. Every point that you see is within 3 meter, XYZ. We have 50 centimeter resolution. Through our technology, we can overlay other images, your own images. We are quite sensor agnostic. We can use small sats, we can use drones, UAVs, and also recce images. You get exactly the same accuracy from those images and points. We can extract coordinates with the same accuracy, and we can use it to navigate in a GPS spoofed environment. With that, I'd like to conclude. Thank you very much.
Thank you, Tommy. And we've had the opportunity to see some excellent pictures during the Galwan conflict, Ladakh. So we are aware of the quality of product that you produce. Well, we are now almost into tea time, but we've got 2 very good speakers, experts, and so we will proceed ahead. Our next speaker is Lieutenant Colonel Vivek Gopal, who is from the Corps of Electronics and Mechanical Engineering. He was commissioned in the Army in December 2000. He has wide experience in electronic warfare and has handled a plethora of systems in a 6-year stint with various electronic warfare units. MTech in communication engineering, the officer has handled various appointments in different terrains, and including in the counter-insurgency and counter-terrorism environment over his more than 2 decades of service in the armed forces. He's received the Army Commander's Commendation in 22. He's a paratrooper and evinces keen interest in latest developments in the field of communication and electronic warfare. And incidentally, he'll also be speaking in the space track later this afternoon. Over to you, Vivek.
Very good morning, ladies and gentlemen. And at the outset, once again, thank you so much, General Chandele, for having given us this opportunity to revisit this forum after 2019, after a gap of 2 years, unfortunately due to the pandemic. Very beautiful sessions that we've heard. 3 speakers before me. We've had Gulshan talking about resilient PNT signals. Then we had the reps from Capella giving us an idea of what SAR imagery is all about. And we also had the latest beautiful videos being played by Maxar. The topic which I have decided that I would speak to you all on is going to be something that deals with this plethora of data that we're talking about, various layers of intelligence, this kind of data which is coming in. How do we actually keep pace with it in times to come? And this is where actually the technology of 5G is something which I'd like to talk about with respect to geointelligence. How do they actually, play hand in glove? And how can 5G actually help us achieve this geointelligence? And what are the aspects of 5G which are actually going to help us out? So before we slingshot directly into the presentation, I would just kind of cover the outline of the presentation. The presentation is basically going to be covering of the various facets of 5G which are going to be useful as far as geointelligence is concerned. And we'll go on to develop a SWOT analysis and a policy perspective specifically with respect to our country, that is India, and what we need to do so that 5G and geoint both can be meshed together so that we can achieve maximum benefit out of it. So without further ado, we'll move on to the first presentation, the first slide. So as you can see, we are looking at what are the main 3 characteristics of 5G which are actually going to be very, very useful for us when we are talking about sharing all this data. So we have the enhanced mobile broadband, that is talking of the data rates. We have the ultra low latency, which is a URLLC, which is extremely small reaction time for data to flow from one point to the other. And we also have the MMTC, or the massive machine type communication, which are the 3 cornerstones of 5G technology. Now, as we've seen with the previous speakers, we have various kinds of intelligence which is actually going to come in when we talk of geoint. We have IMINT, we have SIGINT, we have MESINT, and we also have HUMINT. The question is of how we intend to superimpose all these layers onto a base layer, like was told to us in the case of Maxa. You use a base layer and thereafter build on it with various layers of intelligence. Now, how are the these enabling technologies that we spoke of? How are they going to be enabling geoint? You're looking at speed. You have some kind of data which is getting generated at a particular location. You want it to be transmitted to the commander so that he can take a very rational and wise decision. That needs to be taken care of using a technology like 5G, which is going to offer enormous speeds. The data chunk, when you're looking at visualizations, when you're looking at data rich in vectors, or it's got some kind of a graphic which needs to be sent to a particular point of impact, it needs a certain amount of bandwidth. So we are looking at eMMB, or enhanced mobile broadband. And then we're also looking at a network or a mesh of sensors. Now with 5G, everybody talks of virtualization, everybody talks of NFVs and software defined networking. The fact of the matter is, when we're looking at it with the defense perspective, what we're actually looking at is a defense slice. If that defense slice, which we get out of virtualization, is actually able to support this entire bandwidth and give us the kind of data that we are looking at, then we'll be moving towards this meshing of 5G and geointelligence, and it'll actually be worthwhile that all this data which is getting generated through various layers getting superimposed on one another, they actually get transmitted from one place to another, right up till the commander, so as you can hasten the OODA loop. The middle part, what I've tried to show here is that we are trying to shorten the sensor to affect the loop. At the same time, what we also need to remember is that although we might want this information to reach as far as possible, we have to remember that we'll always be working in an EW degraded environment. Unfortunately, with the kind of backdrop that I have, as General Chandele mentioned, I'm generally an EW guy. Unfortunately, you'll keep finding flavors of EW wherever I talk about it in times to come. So this concept of information provision, information denial, and information deception is something which is always going to be there in the environment. We have to make sure that this data which is coming in, that is in this various layers of imagery that's coming up, actually reaches the commander well in time so that he can make meaningful decisions. Coming on to this hypothetical scenario, what I've tried to show here is, you see the image on the left, that is basically the sensor to affect a network, and you have this in-between layer, which is the C2 layer, which is the one which is actually going to serve as an interconnect between the sensor and the shooter. At the same time, the exploded model of the same, that is the middle image, is where you see as to how the transmission of information is taking place. So here now, in the case of geointelligence, we can assume this to be the various layers which are actually going to be transmitted. So this is the kind of data chunk that's actually going to be coming up in this entire meshing of network that's going to take place right from the sensor to the effector. Now, this hypothetical scenario, what I try to portray, is actually giving out certain relevant research areas. Those research areas is, in case we want that kind of speed that I've been talking about, then we need something like 5G in a box. We need something which is there in the hands of the warfighter so that he is able to connect and get data on his PDA or a laptop or something like that. Like the US Army tends to use the Samsung mobile phones, which are tactically hardened so that they can be used in the times of need. So in case you get that kind of an overlay in your hand, nothing like it. And at the same time, we also need to have systems which are both platform and vendor agnostic. That is because in case, let us say we've got Capella or we've got Maxa, the eminent speakers here, in case I want to use their data, the data has to be such that in case tomorrow, in case India develops a kind of a PDA to be used by the soldiers, then he doesn't really have to fine-tune it or tweak it to suit their requirements. So the data sets that are going to come to us or going to get delivered to us should be such which are actually going to be platform and vendor agnostic. Coming on to how this future battlefield is going to look like, this is just an example to tell you the soldier of the future. These are the kind of sensors that are going to be there as a part of his kit. So you see about 5 to 10 sensors on his left, 5 to 10 sensors on his right, a complete head-up display and everything else. Every sensor is acting like an IoT. It's transmitting information. This information, plethora of information, is actually going to be there, and then of course he's going to be also having encrypted radios. So this is just one soldier, and imagine the kind of data that is getting generated by just one human being who's on the field. When this is extrapolated, we have a situation like this. So now the entire network of communication, command, information that's actually flowing in, earlier which used to be called C5 ISR. In fact, I've tried to add another word to it, and I've said, why can't we use C6 ISR, wherein this 6C is actually going to stand for cognition. So when everything like this actually comes in and we're talking about C6 ISR, what's actually going to be happening? We had one soldier in the previous view foil. Now this entire mesh network actually looks like this. We've got hundreds of systems operating in the entire battlefield. There is data which is flowing into the command posts. From the command posts, some kind of information is going to a cross-functional team, and probably courtesy this geointelligence, where we've got multiple layers, accurate data that's coming in. We've talked about 15 centimeters, 30 centimeters, and we are able to have pinpointed artillery strikes. And after the artillery strike has taken place, something which is very, very essential for a commander is to carry out battle damage assessment. So this geoint capability is what is something which is going to be leveraged to give you battle damage assessment. And this entire information which is actually flowing in is actually also going to be taking place through 5G. So 5G is something which is going to offer tremendous amount of bandwidth, lower latency, and this is how this entire amount of information is going to flow from the sensor to the effector and vice versa. After having seen this, I'd like to suggest a framework. We generally talk about the OODA loop. That is the observe, orient, decide, and act. Here in the case of 5G with geoint, I'll just tweak it a little bit, and I'd like to see it through the lens of something which is known as the DIKW framework. Now, DIKW framework here is data, information, knowledge, and wisdom. So, courtesy the speeds which are going to be offered by 5G, the inherent advantages that exist with 5G, what's actually going to be taking place is this. The data, which I have written is something like the new oil these days. You obtain that from a plethora of resources. Thereafter, you move on to the information part, wherein you are deriving intelligence from those particular data sets which are coming up. Courtesy, the speeds which are being offered by 5G, it flows at a much faster speed. Coming on to the knowledge part, wherein we are extracting information, we are contextualizing that information, how we actually want it to work. And finally, the commander is taking a very rational and informed decision. So it's the same OODA loop. nothing's changed. It's just a way of representing it. But I personally thought that as far as 5G and GeoInt is concerned, this would be a better way to represent the entire concept. At the same time, we also have unmanned systems which are coming in. This was a particular slide which was taken from a show which took place in Latvia. Now in Latvia, they showed this integrated modular unmanned ground system, wherein they were looking at a full-fledged battle management system which was working, sharing geointelligence with each other using layers of 4G and 5G. So this is the kind of system which was shown in Latvia. We also have a similar kind of system which exists for the US, which is also known as the Mobile Integrated Geointelligence System, which is vehicle-based. It's something to a VSAT terminal, which we generally see on the roads. But however, this is a kind of allied network and allied networking which is already there in place. And the concept which I'm talking about, that is using 5G with GeoInt, is something which is already being tried, tested, and evaluated. Now coming on to the use cases of where we actually see geointelligence and 5G actually coming together with each other. We have accurate location fixes. We had one of the speakers talking about resilient PNT signals. We have digital surface models, which has also been talked extensively by the previous two speakers. We have the terrain peculiarities getting highlighted, what was just mentioned. In case the terrain peculiarities are not highlighted, you might need to take an airlift instead of using an all-wheel drive. So this is the kind of information that you actually need, and that is actually what's going to get transmitted using 5G. You have asset visibility across the theaters. When theaters, you want to look at logistic resources, you want the commanders to know where those resources are exactly on ground. How much time is it going to take for that particular resource to reach me, or for your team to reach that particular resource? That kind of information needs to be needs to be shared with speed. That's where 5G is actually going to come in. And then you also have threat simulation and wargaming, the one that was shown like for the air show. It's a kind of a simulation, a much extended and a much better form of simulation that is actually taking place. So these are the use cases, as we can see, of how 5G and GeoInt can be used with each other. At the same time, there are certain threats which would come when you intend to use such kind of a system. Obviously, we had General Chandele in the opening part telling us about the democratization of this technology. Of course, it's become something which is easy to obtain, and a lot of non-state actors might lay hands on them, which is definitely a threat to this kind of an environment. And we're also looking at interoperability, which is, I'll not really say a threat, but yes, an opportunity which is there for us. And I would exhort the academia as well as the industry leaders here to work on this, so that the Army, the Navy, and the Air Force, and probably Marines for some of us, can actually work out on how a meshed network can actually be built in, and we can have interoperable systems, with jointness being the buzzword these days almost in all parts of the world. The opportunities, when we talk about a SWOT analysis, the opportunities that I feel are actually presented is communication protocols. You have this entire network layer which is coming in. You have plethora of data which is actually coming in. What protocol would we want to use which needs to be secure? When you're locking off anything and everything in terms of the defense domain, you want those protocols to be secure. So what kind of a communication protocol are we actually going to be using? Then we are looking at the GIS information which is going to be shared over heterogeneous networks. HETNets is something which has almost become synonymous with 5G networks. How are we actually going to leverage these HETNets to deliver the information which has been collected by these sensors to the end user? Also, we'll need some kind of operating system which can work on these handheld devices that I was talking about, which the soldiers are going to be carrying. And at the same time, with embedded systems, we also need something which is known as over-the-air updates, so that all this information which is actually getting collected can also be transmitted, and any kind of update that is needed can be done for that particular kind of a system. At the same time, the threats, as I said, the first bullet, pardon me again, is talks about electronic warfare. Definitely with a DW degraded environment, however beautiful the layers might be that we intend to work on, but in case you're working on a denied environment, then it becomes very, very difficult for us to actually pass this on. So the SWOT analysis talks about how we are actually going to tap onto these opportunities, and at the same time try and mitigate these threats, so that we can actually have these beautiful data sets which are actually getting collected and generated, getting transmitted to the commander, so that the rational decision making can take place within the least possible time. So what is the way forward? Having seen about what 5G has to offer with respect to geointelligence, what is the SWOT analysis, we've seen the DIK framework, then what is the way forward? The way forward is we need specific planning tools for resource integration. Right now, we've got SAR images, we've got hyperspectral images, we have our own set of satellites. What is the various planning tool at the hands of the commander which is available? Like, I'll again take the example of EW. When we talk of electronic warfare, there is something which is known as the EW PMT, which is an electronic warfare planning and management tool. Some kind of a tool like this which can help you actually plot how my region of operation or how my theater of operation is actually going to look like. So this becomes something which is, I'd recommend to be priority one. You need a planning tool in the hands of the commander so that he can actually decide how the resources are going to be, how and where those things are actually going to be available. Now, because we're talking of 5G, then how do we merge this GIS vertical into the entire gambit of 5G? Although 5G is about to roll out, that's what we are all very optimistic by somewhere around the next 2 to 3 months or probably maximum at the end of this year as far as India is concerned. But where are we looking at GIS actually getting merged with this entire 5G concept is something that we'll need to see, so that they are actually working hand in glove and they don't work in silos. And then we don't really have to take the efforts to actually merge both these things together. An open architecture, which I've already mentioned, that will actually do a lot of benefit to us, because we want the systems to be interoperable and we want them to be platform and vendor agnostic. Computing power, definitely AI, the word AI has to be used, because without that, I believe all presentations are generally incomplete these days. So AI is something which has to be leveraged. And without AI, you can't be, looking at image interpretation, change detection, and all those imagery associated jargon that we like to use. But we can't be doing that till the time we don't really have GPUs working with us who can process that kind of information at that kind of speed that is actually needed. We need spatial database management systems, definitely something which is essential, because this is the way the databases are going to be stored. Right now we are in Delhi, in this particular convention center. Maybe 3 years back, how did this convention center look like? How were the things actually taking place at that point in time? You want to see the entire timeline of events. So if a database like this is maintained, it makes the job very, very easy for the commander. We need to follow a brownfield approach, obviously, because we can't we can't let go of the legacy system that we already have, and we can't just have a brand new system which is actually coming into place. And of course, we'll need to find out, as far as imagery analysis is concerned, even though if it is riding on 5G, where is it that the cognitive element is going to come in from machines, and where is it that the cognitive element is going to come in as far as the humans are concerned? That separation is something which is definitely needed. So these 6 or 7 points are what I feel should be the prioritization before we actually enter neck deep into this 5G and GeoInt mesh network. This is a recommended organization which I have taken the liberty of taking from one of my papers which was published earlier on, wherein I had recommended what kind of an organization we actually need in case we're looking at 5G to come up in India, and especially the defense vertical. So here on the top hand side, I'm not very sure how visible it is, but on the left hand side, in case you look just below the NSCS, on the left hand side, we have a planning subgroup. That is where I would recommend that the GIS vertical be meshed and merged. If that can be done, then the entire talk that I've tried to make over the past 10 or 12 minutes, we'll be able to mesh both these technologies together and leverage 5G to ensure that the entire data which is coming up from the GeoInt sensors is actually sent right up to the tap end or the last warfighter who's standing on ground. So in a sense, the future battlefield, I said, is something which is going to be entirely networked. And of course, the bottom line is that we are looking at getting more from same and same for less. So this is something which is always going to be there. We are looking at a flat structure, something which is fast, mobile, and protected. So in case we have to recommend a geo-intelligence system which is completely going to be built on 5G, then what are the various components that are actually going to be part of it? They're going to be data aggregation centers. They're going to be hybrid base stations. That is the base stations which have evolved over the years, like the basic BTSs, which have moved on to G Node Bs and E Node Bs, and now coming on to planning and management tools that we've already spoken of. Of course, we need to talk of nano satellites and pseudo satellites, something which Gulshan had mentioned as a speaker when we're talking about resilient PNT signals. We have to leverage their capabilities for extending 5G networks, because when you're looking at 5G, we are not only looking at terrestrial links, we are also looking at NTNs or non-terrestrial links. How is this non-terrestrial link actually going to come up? In case a soldier is there at a place which is a GPS dead ground, then despite having a resilient PNT signals, we want to ensure that this data which is collected by beautiful satellites actually reaches the warfighter. So for that, we need to leverage satellites, nano satellites, pseudo satellites. So that is the kind of thing that needs to be done. A PDA or a compatible handset, which is a definite for this data-rich imagery to actually reach the warfighter. The geocoding framework would also have to evolve with the kind of images and with the kind of intelligence that we intend to send to the warfighter. And finally, all of this can actually even help us in creating a digital twin. Like we saw the entire area coming up in 48 hours for the air show, wherein our fighter pilots could actually see that entire area. Maybe a digital twin of that entire model using DSM or DEM elevation models, we are able to actually carry out wargaming and use 5G for sending information as accurate as possible in as less a time frame as is possible, and the commanders can actually wargame that entire area and plan operations to the T. So this is what I feel is how 5G and GeoInt can actually get meshed with each other. And definitely GeoInt in its own stead has a lot of potential, but I'm sure 5G in times to come is going to augment it fully. That's all. Thank you so much.
Thank you, Vivek, for excellent presentation and with all the attributes of 5G, including speed. The last speaker in this session is a naval veteran, Commander Saini, who is a communications and electronics warfare expert of almost 4 decades of experience. He was head of National Information Security Coordination Cell, which is a precursor of the National Security Council Secretariat under the PMO. And it was during his time that institutions such as CERTIN, NTRO, FinCERT were developed. And the first Forensic Cyber Lab, CBI, was set up. I will not go further into details of his experience. His talk will obviously show you all the experience that he has, and we wouldn't like to cut into his time by just reading his bio. But don't worry about time. Take your time, sir. We are only missing little tea time. That's it. Okay.
Thank you, sir. Good morning to ladies and gentlemen, and special thanks to Geointelligence and General Chandele for inviting me here. So a lot of my work has already been done by Colonel Gulshan, so I don't have to worry that how fast I move. So I'll try to be quick. So my lot of work has been already done by the Colonel Gulshan, so I'll not go into details there. I'll quickly show the slides and move fast so that I don't stand between you and the T. So what is PNT means? Position, navigation, and timing. The question which is generally troublesome, and I have come across yesterday and today also, and yesterday also, that time got to do with the navigation and position, and that's problem I'm going to solve right away because there's no slide made. It is a question which has come, and I like to answer that question. What is the importance of timing in the game of navigation and position? You know, we need at least 3 to 4 satellites to get our location, but remember, none of the device of the GPS or Navic or anything has got directional system into it. So you don't get the direction of the satellites. Okay. What you get is basically a moving satellites. These moving satellites have got stable frequency. As with the Doppler, they can find out where they are. One component is Doppler, that is increasing frequency, decreasing frequency. Second component is their location, which is a mathematical solution which is there in your system. And third thing is the time machine, which is their atomic clock, which is there on that satellite. Now remember the light or the EW wave travel at the speed of about 30 centimeters per nanosecond. That's why you keep hearing the word 30 centimeter accuracy. The 30 centimeter accuracy comes actually from that 1 nanosecond error. So every 1 nanosecond error creates 30 centimeter error into the system. So you can imagine what will happen if the timing clock is wrong. So there is a specific time when the signal is released, and when it reaches that person, that time is calculated, that how much delay has taken place, and that's how you draw the circle, that where you are. And then the 3 circles are drawn, or 3 spheres are drawn, or 4 spheres are drawn to find out your location. And that's why the time is an inherent, inbuilt component of position and navigation. Please understand satellite communication. This is an important facet. A lot of people don't understand this particular nuances of the timing importance. So I took it because this question had come up. Remaining, I don't have to do this. This use cases has been dealt with. This list has been already shown. Okay, challenges. What happened is that first thing is we must understand GPS is owned and operated by US Air Force, right? So it is military controlled even today. Number two is it uses L band at least over India and our area of interest, not L5. It has got two parts, military and civil part can be deteriorated over a period of time. And remember the another issue which Gulchan mentioned, that we should be jam proof. Sorry dear, there's nothing called jam proof. Being EW specialist with me Vivek there, he'll say nothing called jam proof. What you can prove is against only spoofing. Yes, that's possible. Jam proof, nothing, because only 50 watt is transmitted by this satellite, and 10 raised to power minus 6 watt is the energy you actually received in your mobile phone. Okay, that's the amount of energy, and overcoming this energy is not difficult, not at all difficult. So you just jam it with the noise, it will end. Okay, so spoofing is possible, and the challenge which is L1 is solving is, I'm getting a bit tactical quickly. L1 is solving is because there's a cloud on the way, there's a tree on the way, there's a gravitational force on the way. The speed of light or speed of EM energy is not constant. And remember, I told you time is an important factor, and any change in the speed will affect your location. Okay, to overcome that, in GPS they have algorithms. So they calculate the algorithm and they push the algorithm to your mobile phones or your GPS devices to tell that what is the error and make corrections for that. That's how it works. We'll see how NAVIC deals with this problem and why we achieve a better accuracy in the same situation. Okay, now we are quickly looking at the GPS spoofing. First case is undertaken by University of Texas in 2013. They proved that they managed to spoof a liner to a different direction altogether. Of course, Indian was involved there. Mr. Bhatti, student who created the system under a professor. Right? Then we had actual case in 2017 where mass GPS spoofing is taken place, where you can see that the ship was actually got located on the airport. This is actual case we have in 2017. After that, this just broke loose world over. GPS spoofing being practiced by many countries. We don't know which countries is practicing it, but Mediterranean Sea was the hotbed in year 2018. In 2019, we have a case where serious case was there, Stena Impero case. In this case, the ship altered course due to GPS spoofing into wrong direction. And I had drawn two maps because to show that international water was very narrow, which place he altered course and entered into the Iranian water, and Iranian immediately captured it. Now, Iranian claims this ship moved. However, evidence shows that the GPS was spoofed and she was moved there by GPS spoofing. So this is the actual case where a lot of heartburn between Iran and Britain took place. Okay, then the Chinese, we found the first crop of circles. What happened is this, you can see on your map various other ships, not just your ship, all the ships on AIS map, which is used by Navy and Merchant Navy also. And they see the AIS map, and here he kept seeing the various ships are taking circles and going around, whereas actually those ships are all anchored or on the berth. They're not there at all. But on the map, on the screen, he was seeing all this ship moving around in circle. So that chap didn't know what to do. He didn't enter. And then there's a GPS spoofing, entirely GPS spoofing case which is there. Now this circle spoofing has become common. Now this is a very interesting case, GPS spoofing, where Iran used it for defense. Okay, we are seeing the offensive part. Now Iran uses the defense, where around the various areas of they want to protect, they introduce the GPS spoofing. So you see the actually vehicle moving in this artificial direction. You see the round circles, actually GPS spoofed, and nobody can enter in the area. That area is GPS spoofed. So you will be physically moved to different direction altogether if you approach the sensitive area of Iran, and that's they're using as a defensive measure and continue to use it. Okay. Then there's a peculiar case. On one particular day, at least a lot of ships across the world moved to one location, Point Reyes, and landed up on the land from all over the world. Nobody knows why it happened, how it happened. Okay, Russia-Ukraine, already Gulshan has spoken about it. Just for the information, US is ready for anti-satellite missiles preparation. The preparation is on right now. That in case the war escalates, they have to defend against it. That's all I'll add into what Gulshan has said already. Okay, we have some attempt in that at India, which is Navik, Bhuvan, and Gagan. I'll not go into explanation of that. Let me come quickly to the Navik. So it is a indigenous satellite system. We'll quickly come to the history, but most importantly is that smartphones will soon have the Navik coming onto that. Remember, it's a different frequency, L5S and Sierra band is used, and because of that, the normal mobile phones or normal devices cannot get the signals. Those signal frequencies entirely different. Okay, quick history is important to understand its strength and weaknesses. Navy has been crying for the satellite navigation for years together, didn't get it. Disaster management authorities also was asking for some mechanism to issue some kind of messaging in particular area of disaster, but not getting. Then Kargil happened, and the US did act where they deteriorated the signal, which was mentioned again. But we thank US for doing that, because that gives the government to think about it and approve the cases, and we are having the Navik, and probably Navik word has come because it has the naval history behind it, right? Then ISRO has signed a MOU with Map My India, so now you will have these maps, very accurate maps of India at least. And then Nirbhaya case happened, and the decision of Nirbhaya case did happen in previous government. This government time, the decision was taken to install the devices. What happened because of that is Navik proliferation and the usage went up. Until unless a particular system usage is extensive and across the board, it cannot be used effectively. So to use it effectively, the numbers have to be high, and that's very necessary part. Then only it can be used. Pure military use, sustaining will become difficult after a certain point of time. It needs certain amount of self-fire to continue firing and continue working, and motivational part. And now ISRO is contemplating to increase the size. Some applications already covered. Type of service, yes, civil and the military. Total 9 satellites were launched. 1 didn't reach, got down on the way. So another one launched. So the total 8 satellite, fully non-operational 1, half operational 1. So we have 6.5 satellites right now in the air. Right, to be more precise, it's 6.5. Because one atomic watch is not working. In fact, we had a lot of problem with atomic clocks. Now we have to put a new atomic clocks on all the system, and you understand the importance of timing. Now use Lima 5 or L5 and the Sierra band is used, because if you remember, I told you in GPS, the calculation while passing through the various areas, the calculation is by algorithm and not by the real. So it can be inaccurate in that sense. So if the magnetic force is different or the clouding is different, your accuracies will be impacted if you use only L1. If you use 2 bands, then the corrections are made, finding the differential between them. There's a mathematical calculation is applied, and the accuracy, that's why, goes up in the changing environment. Hence, the accuracy of Navik is far superior in the real environment and not like assumed and algorithm based. Another advantage is that spoofing become challenging, because 2 satellites are coordinating with each other, 2 frequencies are coordinating with each other. Spoofing with 2 different frequencies in the same manner has its own challenge. Not that impossible. EW chaps knows how to deal with it, but becomes very, very challenging. The only thing available now is to jam it. Yes, jamming can be done, but otherwise not. I discuss about. I'll not talk. Okay, very interesting image, quick image. That's how the satellites are positioned. You see how they look only on India. On the fourth image, if you see, it's only towards India permanently, and that's why they keep rotating. Though they appear to be rotating all the time, actually they're not rotating. They're just moving up and down over India. Okay, that's how it is beautifully designed by ISRO. So that's important to understand, that why we get it, and we get continuous signals. And we always get 4 satellites. There's no occasion we have less than 4 satellites. 5th satellite keep appearing after every 10 second to 15 second to 20 seconds, some fifth satellite is always available to you. So accuracies of 5 satellites is very high. There's the area covered is 1,500 kilometer either side of India, where the accuracy is up to 20 meters, and beyond that is also there, where accuracy is slightly more than 20 meters. That's there. And let's way forward. One is we need an interoperability where various systems are used just to understand the thing. The pilots in the US Air Force have in their watch 3 satellite constellation, one by Russia, one by China, one by US. Right now, they're using it all 3 simultaneously, so that spoofing and the errors can be removed. Even today, they are doing it. So we need interoperability. Then we need that we have to literally, India may nothing happens of its own. Let's get it very clear. Until the executive order is passed, nothing will happen. So executive order is required that NAVIC should be the primary source of GIS, and you can use other thing in addition. Then only something will happen, otherwise won't. The coverage enhancement will have other countries which will have the international relations impact. The chipset is right now by Qualcomm. The problem is that it is a Chinese company and there is no other chipset which is used. Hence, mobile phone only Xiaomi and Chinese phones which are using this can be used for the NAVIC data coming in. We need to have, in fact, government can order that all companies which are making the mobile phone in India and for at least Indian consumption must have this L5 and Sierra band frequencies built into the chipset. Then only it will be possible. And naturally, movement do that. There'll be the innovation will break loose and a lot of innovation will come into the play. And mass use of NAVIC based IoT devices recommended. That IoT devices should use NAVIC because that is easily possible. MapMy India has proven the point. That's all. Thank you. Jai Hind. You can contact me later. Thank you.
Thank you, Commander Saini. I will not attempt a summary of the session because of the lack of time. But yes, one comment based on what Commander Saini said. India had the NAVIC constellations in space orbiting and functional before they had a receiver. It's been now 4 years and we're still looking for a receiver. So, and what you said that if you don't use this in a large manner, then you're not going to develop it, find mistakes and sort of sort out the problems. So all that remains for me is to thank all the speakers for the excellent presentations they have made. And just as a token of gratitude, we'd like to present you a small, won't call it a memento, small gift from our side. Keep sitting.